children, welcome back to the Max class. Today we are going to start a new chapter, Similar Triangles. By studying this chapter, you can understand the general principles related for two triangles to be similar. Let's start the chapter. First topic is angles and sides. In your 8th standard, you had learned that if all sides of one triangle are equal to the sides of another triangle, then their angles of the triangles are also equal. Look at these triangles, children. One large triangle and one small triangle is given. Let's find out the peculiarities of the sides of triangles with the same angles but of different sizes. Here, to compare the lengths of sides, place a smaller triangle inside the larger with the left corners together. Since the angles are equal, the sides will also be aligned. Now, the right sides of both triangles at the same inclination to the both lines, and so they are parallel. Hence, the right side of the small triangle divides the left and bottom sides of the large triangle in the same ratio. You have already learned about the ratios in the chapter Parallel Lines, isn't it? Okay. Then, to make this more precise, let's denote the lengths of the sides of the triangle by letters. Okay. And when we place one over the other as before, we can mark the distance like this. Then the equality of ratios mentioned earlier can be written like this. A minus P by P is equal to B minus Q by Q. This can be simplified as A by P minus 1 is equal to B by Q minus 1, from which we get A by P is equal to B by Q. And if we place the triangles with the right corners together instead of the left, we will get the sides like this. Okay, then as before, we get A minus P by P is equal to C minus R by R. From this, we get A by P is equal to C by R. Let's write together the equations we got from the two different cases. A by B is equal to B by Q is equal to C by R. What does this mean? Yes, the angles of both triangles are 40 degree, 60 degree and 80 degree. In these, A and P are lengths of the sides opposite the 80 degree angle, and B and Q are the length of the sides opposite the 60 degree angle, and C and R are the lengths of the sides opposite to the 40 degree angle. Here, A by P is a number which shows what multiple of the length P is the length A, and B by Q is the number which shows what multiple of the length Q is the length B, and C by R is the number which shows what multiple of the length R is the length C. So, the equality A by P is equal to B by Q is equal to C by R shows these multiples are same. That is, if we pair the length of the opposite equal angles as AP, BQ and CR, then the longer lengths, that is A, B, C, are the same multiples of the shorter side P, Q, R. In other words, the number ABC are got by multiplying the numbers P, Q, R by the same number K. A is equal to KP, B is equal to KQ and C is equal to KR. The general principle behind this is, in two triangles with the same angles, if we pair the sides opposite equal angles, then the longer sides are the same multiples of the shorter side, or vice versa. In other words, we can say that the sides of triangles with the same angles taken in order of size are in the same ratio. Or else, this can be stated in yet another way. We use the term scaling in comparing two measurements in terms of multiples. That is, in triangles with the same angles, sides opposite equal angles are scaled by the same factor. Okay children, let's do an example. In the figure, angle P is equal to angle C, angle Q is equal to angle A and angle R is equal to angle B is given. Calculate the lengths of the other two sides of the small triangle. So here we want to find the other two sides of the small triangle. For that, let's take the angles as x degree, y degree, z degree and mark equal angles in both the triangles. Okay, after that, let's write the pairs of opposite equal angles in both the triangles. That is for x degree. For x degree angle, the opposite sides of the x degree is BC in the first triangle, and then in the second triangle it is PR. Okay, and then for the next angle, that is for y degree angle, the opposite sides are AC and PQ. And then last, for x degree angle, the opposite sides are AB and then RQ. So here the side BC is of 4 cm and then the length of the side PR is not given, and then the side AC is 6 cm and the pair of opposite side, that is PQ, is given as 3 cm, and after that AB is given as 8 cm, and we don't know what's the length of RQ. Let's find out that. Here the length of all sides of the larger triangle and the length of one side of the smaller triangle is given. That is for x degree, BC is equal to 4 and PR is not given. And for y degree, AC is equal to 6 and PQ is equal to 3. And for Z degree, AB is equal to 8 and QR is not given. Here the sides opposite the y degree angle, the smaller is half the larger, that is 6 cm is AC and PQ is 3 cm. So the sides opposite to the other angles must also be related in the same manner. That is for x degree, BC is equal to 4, then PR is equal to 2 cm, and after that y degree, AC is 6 and PQ is equal to 3, and then for Z degree, AB is equal to 8 and then QR is equal to 4 cm. Thus, we had found out the other two sides of the smaller triangle also. Okay children, in the next class, we will discuss the exercise questions related to this. That's all for today. Thank you.